Let me share my screen again. And so 3 by 3 by 3, what we have, so we multiply 3 by modules of A1. And what is the cosine of between cosine of the angle between these vectors? And
0.
Are you sure? So the angle is 0, but the cosine?
1.
Yeah, 1.
Yeah.
Yeah, so
I missed it up.
yeah, don't confuse with the sign. Okay, plus 6 multiplied by 3. Oh, by the way, we can just add, so 6 minus 4, so plus 2 by 3 by 4. And cosine of this angle is minus 1 second. So it's this value can be taken from the table. And minus 4 by 4 by 4. Minus 2. Sorry. I have a mistake. So here A2, A1, A1, A2, and yeah, just made a mistake. And here 2 by yeah, and 4 by 4 by 4 and by 1 because of 0 angle. So 27 plus 12 by 4, 48, divide by minus 2, minus 24, and minus 64. So 27 minus 88 equals minus 61. Any questions about this task? Maxim, yeah.
I have a question about the notation. So A1, comma A2 in the parentheses, it is not a scalar product, but the cosine?
No. So this is the form, just a symbol of a scalar product. So we use this, or we can write in this way. And to evaluate.
Yes, but in the task we had like this notation.
Yeah, but this notation means angle. So this.
Okay, I got it.
Yeah, so it is the angle. So you can write it in such way, just not to confuse, not to lose. So we also can write in, like this. And if without this angle character, so just it is a scalar production. Other questions? No questions. Okay. Let's move next. Uh-huh. Okay, let's solve this task, number 2. How to solve, by the way? Any ideas? Raise your hands. So, what do you think about it? What about new people? Maybe Alexander Dolmatov? Any ideas?
Certain-
N- uh,
Mm, actually, I don't have the ideas. I don't know.
By the way, we should find alpha for which vectors are orthogonal, but if vectors are orthogonal, so what is their scalar production?
Zero.
Yeah, zero. So we need to do almost the same as for the previous task, but we will have the equation for. So yeah, we need to multiply b by c, and it will equal 0. And let's write it in details. Now let's not confuse alpha with a, by the way. And what we have, a1 multiplied by a1 plus alpha minus alpha a1 multiplied by a2 plus alpha a1 multiplied by a2 and plus and minus alpha, so square alpha, and a2 by a2. By the way, these addends are eliminated, so minus alpha plus alpha and the same productions. By the way, it's like a formula of shortened production from that we know from the school. So it looks simpler. And now, so yeah, and what we have, 3 by 3, because we multiply the vector by itself, minus alpha and 4 or 5 by 5. And we have the equation that we need to solve respect to alpha. So alpha, so 25 square alpha equals 9. And now, and alpha square equals, and the power of 2 equals 9 by 25, and alpha equals, so 2 roots, 3/5. Any questions about this task or not? No questions.
No questions.
Okay, no questions. So let's move next. Mhm. So task 3, we have triangle with 3 vertices, A, B, and C. And we need to find cosine of angle A. For this task, let's better make so write a figure just for better understanding. So A, B, and C, and we need to find the cosine of this angle and how to solve it. Maxim?
We can find it from the theorem of cosines.
Yeah, we can, but how to use it? So, how to find it using just... by the way, yeah, we can with theorem of cosines, but we need to find cosine of B, cosine of C. It will be quite long, but we just need to use the scalar. Yeah, by the way, for cosine's theorem, we need a scalar product as well. But how to make it simpler? Any ideas?
We need
What?
to.
So, yeah, by the way, don't forget to raise your hands. Yeah, Mikola?
I guess we need vector AB divided by AC.
Yeah, so vector AB divided by...
AC and 2. Is it correct?
If we had the straight angle triangle, it could be, but really we don't know anything about this triangle. So we just need to use a scalar product and how to do it. Okay, Daniel?
We can find firstly scalar product of vectors a, b, and ac. We are using in this moment their coordinates, and after this we find magnitude of these vectors and find from scalar product cosine.
Yeah, so what do we actually have to do? So vector A, B multiplied by vector AC and divide by production of their models. So Mikola, Maxim, and everyone. So did you understand what I mean? So we don't know modules of vectors, but we can calculate them, and then we will get the cosine of this angle. So any questions or no questions? Okay, and now let's write the coordinates of vector AB. So how to calculate them, first of all?
From the end,
Maybe any, so new people, Artem Turchin, do you know, do you remember how to calculate the vector between, so vector AB, its coordinates?
Um, mm, we need to
Like, як буде відняти?
Subtract.
We need to subtract from the ends.
Mhm.
We need to subtract the beginning, and this is all we need to do in square.
No, we don't need a square here. Just subtract coordinates. And what we will have?
Okay.
Minus 2, it will be -4. Then 2 plus 1, it will be 3. And 5 minus 3, 2. So actually, that's these are coordinates. Okay. So Artem, could you help me also? So just to make sure that you understood, could you help me to calculate coordinates of AC?
It's like -1.
Yeah, -1. Then
3
mhm,
and 0.
and 0. Yeah. Okay. And now we need to calculate vector production, scalar production. Vector production will be a little bit later. Okay, and now let's calculate. Let's calculate it. Who wants to take part? Maybe Masha.
Okay. We need to find again. I'm sorry.
So,
Do we need to find the length of these two vectors?
firstly, let's calculate scalar production of these vectors. We know their coordinates and how to calculate. If we know coordinates but don't know length. So we need only these coordinates to calculate the vector production, the scalar production of vectors.
-1 multiplied by -4.
Mm-hmm.
And this would be 4.
And then?
Then add 9.
Yeah, so 3 by 3, actually add. Mm-hmm. And
0.
yeah,
0.
because 2 is multiplied by 0. And so 4 plus 9, it will be 13. So actually nothing frightening. Okay. Daniil, you have any questions or you just want to answer?
I forgot to.
Ah,
I forgot
okay.
to.
Okay. And now let's remember how to calculate magnitudes of vectors, because we need them as well. And Stanislav, yeah, go on.
It will be square root.
Mm-hmm.
-2 minus 2 powered by 2.
Sorry, what here? What is?
Can you hear me?
Yeah, I hear you.
minus 2 powered by 2.
No, why -2 minus 2? So look just at these coordinates. So without this, yeah,
Yeah.
just
It
this.
will be 16
Yeah,
plus 9 plus 4
but let's write in details now.
plus 3 powered by 2 plus 2 powered by 2.
Yeah, and so 16 plus 25, plus 9 plus 4. And it will be square root of 29. And we will leave it on so in this way. And AC, who wants to
Will-
help? Actually, analogically. So -1 in power of 2 plus 3 in power of 2 plus 0 in power of 2, and it will be square root of 10. And now we just substitute into our final formula. So 29 by so 13 divide by square root of 29 and divide by square root of 10. And the square of 13 will be 169. And this production will be definitely, so let's write in this way just to verify that the cosine is less than 1, or less or equal. So the square root of, so 13 is the square root of 169. So just don't forget to verify your cosine value. Any questions about this task?
No.
Okay. Okay. Then let's move to the next task. For task 4, we won't solve now, but I have a question about the physical usage of vector of scalar production of vector. How to solve task number 4? Who knows? Just how to solve it will be like your homework. So, okay, Daniel.
I think we can put coordinates of A and B into this equation.
Which equation?
If equal E y plus 2G plus K.
So, how to find the work of force if we know force and a vector of movement? Okay, Mikola, maybe you remember. Yeah.
Maybe. I think first we should store the vector AB, and then every each coordinate we replaced with each values in formula.
Actually, no. So the work of force is a scalar value, and it will be calculated in this way. So if I'm not mistaken, it is so it has a W symbol in the physics. So scalar multiplication of force and vector AB, and that's it. So it's simple. Just physical usage of scalar vector production. Okay. And now let's go to next task. Oh, by the way, maybe any questions about task 4?
Oh, how about the answer? It will be 3
Okay.
minus 2 and 3.
Okay. Let's calculate it. Calculate it after the lesson, because just now we don't have enough time. And the result must be just a number, not a vector. And we need to move to other topics. But then compare your results, of course. And now let's move to task 5. And the next question, would you remember about the vector production of vectors? Who remembers? So raise your hands. So you don't remember? No?
You're talking about the maybe cross product, yeah?
Cross product.
Formula A multiplied by B
Mhm.
multiplied by sinus.
Yeah, correct. Cross product, just a little bit incorrect translation. Yeah, cross product definitely. So by the way, and yeah, so actually, if we know their modules, and if we don't, by the way, not cross product, but vector product, and cross product. So just let me look into the literature. Mixed product. Yeah, or maybe other. So it can be called other ways. Yeah. So vector product is also the vector. So we can record it in this way. Yeah, and cross product actually can be, because we also write it like that. So as you like it. And module of yeah, let's write. So it will be equal to C, and their module of C will be equal module of A multiplied by module of B, and multiplied by sine of a sine between so a sine of angle between these vectors. So this. Okay. Also, which rules of vectors, vector production do you know? Which properties that we need now? Who remembers? Like some of them are similar to scalar
The
production.
vector product is not commutative.
Yeah, and anti-commutative. So it means that if we change places, of vectors. So it will have the opposite sign. So A multiplied by B equals minus B multiplied by A. So it's anti-commutative rule. And actually associative and distributive the same. So A multiplied by alpha B equals alpha A multiplied by B. So we can move coefficient out of brackets. And associative rule okay. Oh, by the way, it's time to have a break for now. Let's have a break for 5 minutes and then we will continue solving the task. Because you definitely need to have a rest, me as well, and then we will continue.
You will leave the demonstration.
I can turn it on, so without turning off, of course, if you need.
Yeah, just leave.
Okay. Okay, let's continue. So, how to solve our task? So firstly, let's do it in this. Oh, no. So, yeah. So we need to say uh, to calculate it with using associative and distributive rule. And
Can I try?
yeah, go on.
It will be 2 and multiplication vector a1 a1
Mm-hmm.
plus 4 multiplication vector a1 a2
Mm-hmm.
plus multiplication vector a2 a1, but we can write it in another way. It's so multiplication vector a1 a2 multiplying by -1.
Yeah, we can write in this way. So a1, a2.
Minus a1 a2.
Yes. So a1 by a2 by a1 equals a1 minus a1 by a2. Yeah, correct.
Plus 2 vector and multiplication vector a2 a2.
Okay. And
And
then
then it will be 4.
yeah, let's simplify. By the way, how can we simplify? Maybe some of these components will be eliminated.
Yeah, 4 multiplying by a1 a2 will be 3 multiplying by a1 a2.
And what else? So just not
And
elimination.
first and last, we just multiplying by 1.
Are you
So
sure?
cosine.
So module of vector multiplication, vector product equals product of their vectors multiplied by sine of angle between this vector. What is the sign between a1 and a1?
0
Yeah. So we just
will be 3.
eliminate these components, and our task becomes much simpler. So 3
3 multiplying by
module
product
of,
vector a1 a2,
yeah,
and
and
it will be 2p.
so it equals 3 by 1 by 2 by sine over 2p by 3. But let me remember the sign because I don't remember this table. So sine of 2p divided by 3. Okay.
Probably 45.
So maybe square root of 3 divided by so square root of 3 divided by, yeah, it's square root of 3 divided by 2. So 3 by 2 by this. And we have 3 square roots of 3. Any questions about this task? So no raised hands, and it means that no questions. Or Mikola, maybe you have a question. Oh, okay, muted.
Yeah, I have, but I
But ask
can't ask it
ask
in the right way. Okay,
okay.
what about our last solution? I don't
Previous
understand how
task.
we did it.
So what do you mean? The final result or what?
Yeah, final result
So
and
here is
previous
the
one.
formula. The module, we need to calculate module of vector production. And this is the formula. We take module A, module of, so magnitude of A, magnitude of B, and multiply by sign. And what we have? We moved 3 out of module sign, and then we multiply it by magnitude of A1, which is that is equal to 1, multiplied by magnitude of A2 equals 2, and multiplied by sign that equals square root of 3 divided by 2. And that's actually what we have. Or so, do you have a question about this point, or maybe before?
No, I just had a mistake in my solution.
Oh, so now you understand what you mean.
Yeah, thanks.
Okay, maybe anyone else has questions, or no? If not, let's go next. By the way, now I have a question. So we need to. So how to maybe okay ask how to ask you correctly. So which geometrical properties of vectors of vector production do you know? How to use it? So the application of vector production. So no idea.
It's built a feature.
Sorry?
It is building a feature.
I don't understand what you mean. Maybe write in the chat.
Can you hear me?
Yeah, now I hear you.
It's built a feature.
Build a figure.
Yes.
Yeah, so we have yeah. So it is related to figure, and so how to use vector uh, product. Okay, let me remind you. So for the triangle, it will be equal to 1 and 1 second module of vectors of vector production of vectors that build the triangle. And for parallelogram, so just module of vector production. And actually that's it. Just what we need. So do you understand what now we are going to use here?
Yes.
Yeah, and what firstly do we have to find? The new?
Cross product of
Yeah,
C
cross product of C and D. Correct. Okay, let just handwriting will be much simpler. So 3A plus 2B, and it will be, so what, oh, by the way, we don't have a lot of time to solve it. So you know how to solve it, actually. So to get the final result, we need to calculate the module of these vectors. Oh, but okay, let's do it quickly. So we calculate module of, so 3 A by A plus 2A by B. Okay, so let it be, so plus 6A by B, because of an anti-commutative rule,
And minus 4.
and minus 4B by B. But we remember that these components will be eliminated, and it will simplify our calculations. And so what we have, minus 2, module of minus 2A by B. Remember that, yeah, don't lose module. And what we have, 2A vector product A by B, and 2 multiplied by 5, multiplied by 5, and multiplied by sine of P divided by 4. So 2 by 5 by 5, and square root of 2 divided by 2. And it will be 25 square roots of 2. And the area of triangle, so we just have to not to forget multiplied by 2, and so 25 square roots of 2 multiplied by 2. Any questions about this task?
Yeah, I have.
Yeah.
How we get from the end of first line, second. We
so-
have 3 AA vector plus 2.
Yeah, my
It's
bad.
A.
My
It's
bad. Yeah. So thanks for your attention. But by the way, if you see something suspicious during the lesson, just feel free to raise your hand, please. Yeah. So that was the mistake. Feel free to raise your hand and correct the mistake earlier that we can do it. Yeah. One more question.
It will be -6, but not +6 because -2b to
minus 2b multiplied by 3a, and the anti-commutative rule. So it will be, yeah, so minus 6 b multiplied by a, but we just changed the order. Okay, I will write it here. So it
I
equals.
understand. Okay.
Oh, okay. So just for more convenient calculation. So, and as the result, 50 square roots of 2. Okay. Now let's speed up. By the way, now let's calculate just cross product of two vectors. So we know coordinates over two vectors and how to calculate it. So who remembers? So with knowing coordinates, without knowing modules. So raise your hands. Yeah, Mikola, don't forget to raise your hand if you want to answer. Yeah, go on.
Okay, we just need to multiply coordinates and sum.
No, that's for scalar product.
What we need now?
And this is a cross product or vector product.
We need to calculate the vector.
Yeah, it will be the vector as the result. So do you remember, or maybe anybody else? Okay, Daniel?
We can use the matrix. Right.
Yeah, matrix, actually the determinant of the matrix.
Yeah.
So this determinant, and the first row will be ijk, so our unit vectors, and then we will write our vectors. So what we have for I plus 2j plus 3k. Okay, just believe me that it's k. Minus 2k minus 3i minus 4j. And it equals, so I minus 2j plus k. And by the way, what do you remember about swapping two rows or two columns over the determinant? So if I change places of between these vectors, what will happen? So between these rows. Yeah?
It will be negation.
Yeah, so it will, so it just the proof of anti-commutative law, anti-commutative rule, or just like maybe not proof, but it's like so that follows from it. So it easily can be verified. Okay, and now let's go to mixed vector multiplication and their usage. And what does it mean? So how to calculate it? So how to calculate a mixed vector product? So, and how to write it? What is it actually? Is it a vector or is it a number? Mykola?
It's from the presentation. It's a scalar product of a vector product and the third vector.
Yeah, so two vectors multiplied. So actually, how can it be written? So a different way of recording.
Like
Usually,
we can write it like a matrix.
yeah. Actually, it will be determinant. Yeah, but
Oh yeah,
yeah, or just ABC like that. We can do. And yeah, so looks like that. And so it's, yeah, so scalar production of cross production, so multiplied by the other vector. So this one. Okay. Yeah, and now let's calculate. By the way, so here we have spoiler, but what is the geometry geometry usage of mixed product? Daniel?
We find volume of parallelepiped.
Yeah, correct. And which else which else figures can we calculate?
OBM.
Yeah, OBM. So OBM is the volume. Yeah, so volume of parallelepiped, OBM parallelepiped. And which else figures except of parallelepiped? Okay. Daniel, yeah.
Triangular pyramid.
Yeah, triangular pyramid, and but will it be the same? I guess that no, that not.
We need multiply by 1/6.
Yeah. So okay, let me write. So volume of parallelepiped will be look like that, and volume. Ah, by the way, module, of course, because the volume cannot be negative, but the production can be. And volume of the pyramid will be 1/6 of this module magnitude. Okay. And now let's calculate our mixed product. So A, B, and C. Let me copy and paste to save our time. So, and we remember that we must write vectors as rows. Oh, on. Oh, no. Not rows, but columns. Yeah. So 2, 1, minus 1, 1, 1, 3, 3 minus 4, 2. So 2 by 1 by 2 plus 1 by 3 by 3 plus 1 by -4 by -1 and then minus. Yeah, Mikola, you have a question?
Yeah, it's incorrect. We need to write like rows.
Yeah, transpose. Okay, let's transpose. But anyway, so
Yeah, we will have the same result.
yeah, the same. So let's just live in this such way. But don't forget that if you started writing vectors like columns, all of them must be columns. If you write in a row, so write all in a row. So the determinant of transpose matrix equals the determinant of original vector matrix. Yeah. So just the useful property. But that's good that you are so attentive. So 4 plus 9 plus 8 minus 3 plus 24. Minus 24. Minus 24. Don't lose signs as I do. Plus 2. -21. Minus 20, plus 26. And it will be 47. And as we have a mixed product positive, so here is the volume of our parallelepiped. Will be 47. Any questions about this task? Oh, no, minus 25. My bad. Yeah, Daniel?
I think it will be plus not 8, but plus 4. I go.
Yeah. Just a mistake. So let's correct it. So it's 17. And here was 25, by the way. So incorrect.
I have 39.
So
Oh, I get it.
yeah, it's a good question. And who else? Anybody else has 39? So let's compare our answers. So it seems that maybe you have a mistake. So here, 17 plus 25, 42. And by the way, volume of pyramid will be just 42 divided by 6 will be 7. And you need to recalculate. Okay, we have some time. Maybe you have questions about this task. No questions, right? Okay, and the next question, how to check if the vectors are complanar or not? So with using productions of vectors. So raise your hands. Who remembers? Maybe anybody else? So I haven't heard a lot of people for ages. Maybe Daria? Do you remember?
I don't remember.
Don't remember. Maybe do you remember something about how to check it with using a mixed product? Okay, Eugen?
Component vectors is vectors that lay in the same plane.
Mm-hmm.
We can check if the vectors is coplanar if their scalar product is 0, I think.
Not scalar product, but other one. So
Cross products.
not cross product. So we need to check. We can choose three coplanar vectors. So two vectors always will be in the one plane, but we need to check if three of them are aligned on the one plane, if they're coplanar. Maxim, I saw your hand as well.
So if the scalar product of three of these vectors equals to 0, then these vectors are coplanar.
No, not scalar, not scalar product. Okay,
Vector product.
not vector product. We need three vectors. So we need to check that three vectors are coplanar. A, B, and C. Okay, Daniil.
Scalar triple product.
So just this mixed product. So yeah,
Yes,
scalar
yes.
triple, yeah. So just this kind of product should be equal 0. In our task, in this case, it's not equal to 0. So then we just verify that, yeah, if they were coplanar, we would have no ability to calculate, to build a parallelepiped on them. Okay, and now let's solve quickly a task related to it. Task with the lucky number 13. So we need to find value of lambda for which vectors A, B, and C are coplanar. And of course, we need to calculate their mixed product. First of all, so we will have such a determinant. Now let's write in row, just not to get confused. Minus for lambda, minus 6 plus 25, minus 1, minus 10 lambda, and minus 60. Okay, and let's calculate it. So minus 16 lambda. So 60 minus 67 plus 25 minus 42. Yeah, so minus
You
67.
missed the lambda.
Minus 10 lambda. Yeah, minus 16 lambda, correct. So minus 16 lambda minus 40.
Maybe minus 14
16.
lambda.
Minus 14 lambda, yeah. Sorry. Minus 14 lambda. Minus 14 lambda equals minus 42. And minus 14 lambda minus 42 equals 0. And now we need to solve such simple linear equation with respect to lambda. So lambda equals minus 42 divided by 14. It equals 3. So that's it. Okay, verify it at home, and I will look just other tasks. Okay, I will ask you just how to solve number 14, and you will do it at home. Or maybe you have questions about this task, number 13.
Yeah, you have a mistake. It
Where?
will be minus 3.
Sorry?
It will be minus 3.
Yeah, thanks. Losing signs, it's a bad practice. Thank you for your attention. Maybe more questions? So just raise your hand if you see that something is going wrong. Okay, no questions. So let me copy and paste this one. So we have 4 points, A, B, C, and D. And we need to prove that all they are aligned in the same plane. How to solve it? Any ideas? Maybe anybody else wants to join our discussion? What about Sophia? Any ideas how to solve? So we won't solve it now, just the idea, the way how to do it.
No
You
ideas
can?
because to define that they are on the same plane, we need to calculate determinants. Yeah, and determinant is need to be square. But here we have 4 vectors.
We will.
So I don't actually understand how to build determinant.
So we have just 4 points, and we need to verify. Yeah, we will have to calculate determinant, but not. Of course, we cannot do it for non-square matrix. Okay, Mikola, maybe any ideas how to do it?
Daniel raised his hand earlier.
Okay, Daniel.
Okay, I think it will be that their mixed product must be 0.
Mixed product of which? Of what?
I think first 3.
So what do you want to multiply?
What about, firstly, we saw the triple scalar product of A, B, C and check will it equal 0 or not. And then we solve with B, C, D.
Okay, but here is attention. A, B, and C, and D, they're just points, not vector. So, yeah, the triple product is correct, but you are losing something, missing some big
Firstly, we should find the vectors.
Yeah, so vectors. We need to calculate A, B. So we just need to calculate triple scalar product of these vectors AB, AC, and AD. You can choose other points. So, but all of them must go from only one point. So you can also calculate BA, BC, and BD. And yeah, so don't forget that all of them must go from one point. So actually, that's the idea how to solve. Any questions about this task? Or about lesson as well, maybe previous lessons? Okay, it seems that you have no questions, so have a nice day, stay safe, and I will share all materials. So I will share, I have already shared a file with the tasks, and I will share recording with you. So bye, have a nice day.
Okay, thank you for listening. Bye.
Yeah, thanks for your attention.